3.4, we are working on checking arguments for validity. I got another two-premise argument here. Sorry if you're sick of the purple at this point. Actually my favorite color, but not quite this purple. For efficiency reasons, I'm going to stick with the purple here for a little while and keep this 8-row table over here, 8-case table, sitting here. We're not going to use it this time, but in the next clip I'll come right to it. Okay, argument 2 here, first premise, P or not Q. So I'll enter that in my first column, abbreviate it with a P1 for premise 1. Second premise, if P, then Q and P, and both Q and P, we would say, making clear where the parentheses go. All right, and our conclusion is Q and not P. All right, so then we do our calculations, and again we're looking for a case or a row reading across horizontally to that has all true premises and a false conclusion. In this case, both true premises and a false conclusion. All right, so as soon as P is true, this expression, the first premise, P or not Q, is true. You can kind of write that in quickly here. In the next case, it's going to be false. If we make a little notes here, P is false. And not Q is false, so I wound up with false or false, which is false. It's going to be true in case 4. P is false, not Q is true. It's an or statement where we only need one of the two claims to be true. We can have both as well for it to be true. All right, moving on to the second premise here. Let me speak to a little bit of efficiency in terms of calculation. We have an if-then. And an if-then is false only when we have T horseshoe F. Therefore, if the antecedent, the first part, is false, the claim is true. So in cases 3 and 4, P is false without even bothering thinking about what's in the parentheses in the antecedent. We know the claim is true there. We're going to wind up with T horseshoe T in the first case. It's true. In case number 2, we're going to wind up with T horseshoe F. Why? P being true, with P true and Q false, excuse me. We get an antecedent on the left, true, horseshoe, and then it's false and true, which is false. So it's a T true, horseshoe, false, if true, then false, which is false. All right, calculate for the conclusion. Going with the efficiency is pretty simple. Q, it's an and claim. As soon as Q is false, it's false, so I can go ahead and say that the second and fourth cases are false. In the first case, if you calculate out in virtue of P being true, it's going to be false as well. Q and not P. Well, case 3, that's exactly what we have, Q and not P. It's true right there. Okay, so now I'm looking to see if I ever have all true premises and a false conclusion. Deliberately in this case, we have it twice in case 1 and case 4. Definitely still an invalid argument. If you look at case 1 here, reading across, first premise is true, second premise is true. Conclusion is false. Same thing happens in case 4. First premise true, second premise true, conclusion false. So we can say it either would be sufficient here. I'm not going to play games with this on the exam, but we can say invalid. To be complete here, let's say let P and Q be true, or let, forgive me for this not being lined up, P and Q both be false. I probably would have been best to say both up here as well. It's invalid. Let both P and Q be true, or let both P and Q both be false. This would be the same in the context here.